of all, see, there was one ground signal. I mean, there was one ground which was present for both RE and CE, but to make sure that there is a certain voltage drop across base emitter junction, so we connected negative voltage to the emitter side, but this particular capacitor, it is grounded. Okay, I mean the another side of the capacitor, it is grounded, but again we are facing same issue. We cannot fabricate this particular capacitor. Why? Because we are dealing with IC level, right? So to counter this particular issue, we will require one component such that it should provide less resistance to the AC signal or to the small signal. Well, just try to think in your mind, because we both are engineers, what component you might use to instead of capacitor, which will eventually consume less space and it would work efficiently as our capacitor was working. So to counter this issue, we connected what? We connected one transistor over here in this way. Now I know you might scratch your heads and will ask me, sir, like why exactly you are connecting this transistor in this way? Is there any reason for it? Yes, of course, because if you see the impedance offer between these two junction, it is less. I know it will sound little crazy to you all guys. I'll explain that particular part. Let me just write over here. Let me just draw one kind of small diagram. So the impedance offer over here, it is what? It is very less. It is very less. Impedance offered by this particular part, it is less. See, again just look at this particular part. This was our capacitor. So we needed one component which can replace this particular capacitor. What was that Z? This particular Z should be such that it provides less resistance to the AC signal. And to counter this particular issue, we added one transistor. Why? Because this particular junction of this particular transistor, it will provide less resistance. And now we are going to see its reason, how exactly it will provide less resistance. So let's come to this particular part. See, this is our transistor base collector ammeter, right? This is base collector ammeter. Now come to this particular part. This is a T model. When we are talking about T model, we have one resistor available which is known as dynamic resistance. Dynamic resistance RE, it is nothing but VT by IC, right? I hope you all guys know this because we had already studied this particular part. Okay, and when I'm talking about dynamic resistance, you can clearly see over here, this is RE connected between base and ammeter. So there is one virtual resistor available between base and ammeter. So let me write over here, this is your base and this is your ammeter. This is my base and this is my ammeter, and there is one resistor available over here which is known as RE or the dynamic resistor. Okay, let me erase this part, not needed to show over here. Okay, and the value of RE, it is very, very small. Typically it is around 20 to 40 ohms. Let me just show it to you. Let's assume for time being, we'll just consider random numbers. Let's assume my VT, and VT is almost fixed. It is around 26 millivolts, right? This IC, let's assume for time being, whatever the current that is flowing through the collector and ammeter, it is 1 milliampere. I know I had not connected the collector anywhere. Then you will ask me, sir, how exactly the current is flowing through this particular path? For time being, we will assume, just assume that we had connected this particular collector terminal to some external source. Okay, and from that particular source there is one current of 1 milliampere that is flowing through this particular transistor, right? So for time being, we'll assume this as 1 milliampere. So you can clearly see this milli and milli is getting cancelled, and we are getting RE as around 26 ohms. So generally or typically the value of RE, it is roughly around 20 to 40 ohms, or it might exceed, or it might go it might decrease, but generally it is in few ohms only. Okay, generally it is in few ohms only. I hope you are getting this particular point. So you can clearly see it is around 26 ohms. It would be around somewhere around 50 ohms or 20 ohms, something like that, right? So you can clearly see it is providing almost negligible resistance or very less resistance to the AC signal, and that's the reason that why we are actually connecting a transistor in this way, okay, or in this particular fashion. You can clearly see the base is grounded, the ammeter is connected to this particular terminal, to the ammeter part, and this is what we had done in case of capacitor as well, right? Great. I hope till here everything is crystal clear to you all guys. Great.